Before doing example 3, let me just remind you of certain things. What's the connection between algebra and geometry. So if I have a length piece of ribbon for 5 feet and I put it along another piece of ribbon that maybe is 2 feet, then the question is how long is the entire string of ribbons? So you will say very quickly that that will be 5 plus 2, which is 7 feet, and you will be absolutely right. But what if, because that's what we like, what if we don't know one of those measurements? So whenever we don't know something, that will be called x or y or z or whatever it is, and the measurement will be in feet. So the total length of something like that would be 5 plus that amount that you don't know. Okay, so when I ask what is the length of this piece of ribbon, it would be 5 plus x feet, and that would be just one quantity in the same way that we have managed quantities so far. So let's go back now. And what if instead of having a ribbon that is only one dimension, if I have a plane in which there's a square that measures 6 by 6, and I ask you what's the area? Well, the area of something like this, you know that it measures 6 units, 1, 2, 3, 4, 5, 6 units this way and 6 units that way, then the area would be 36, because area refers to how many squares you can fit in here. So if you know you have 6 rows by 6 columns, then you have 36 squares. So this will be 36. And if we're talking about feet, then this would be 36 feet square. But if instead of that I have a square of side x, or I don't know the side of it, and I want to call it x or y or z, let's call it y just for fun. If the side measures y, then each side measures y, and that is because I know it's a square. If they told me that it was a rectangle, then I wouldn't know what it is. So if this is a square of side y, that means the side, every single one of them measures y. So if I want to know something like the perimeter, well, I know what that would be like, although I'm not going to know the exact number. So the perimeter will be, I'm going to add every single side. So y plus y plus y plus y, it would be 4y. Okay, I don't know how much is the exact perimeter, but I know the expression that would lead me to it would be 4 times y. Now in the same idea, working with this square of side y, what would be the area of a square of length y? Well, it would be the area, again, the number of columns times the the number of columns times the number of rows. That would be y squared, or y times y. Now let's say that I have a rectangle. Okay, so in a rectangle, you can call it whatever you want. You can call it base and height, okay, or you can call it length. Forgot to spell length and width. Either way is fine, as long as one side gets one name and the other side gets another name. That's fine with me. If you don't know the width, you can call it W, you can call it X, you can call it anything you want. Let me call it, I don't know, T. So if the width of a rectangle is T, that means this other length, I don't know it either, but I know they are the same. So this will also be called T. Now, they may give you in a problem, the length is twice the width, or the length is 10 more than the width, or whatever that is. Let's say that they tell me it's 10 more than the width. So we have to translate what that means. Well, it means that the length is 10 units longer than that. So 10 units longer than that implies addition. Oops, sorry. So with those two pieces of information, then I can write expressions about the perimeter. In the perimeter, I will have to add each one every side. So I have t plus 10 plus t plus 10 plus t plus 10 plus t. Okay, did I add all of them? T is this one, 10 plus t is this one, t is this one, and 10 plus t is this one. So I added all four sides, and I just have to simplify it because I have to show you that I know what 10 plus 10 is, and I know what the expression is for t plus t plus t plus t, 4t plus 20. Okay, and if I have to write the area in terms of those variables, again, I just have to remember what the area of a rectangle is the number of columns times the number of rows. So the area would be 10 plus t times t. Now I could just leave it, I'm just gonna write it beautiful. We don't need that many parentheses, we only need a pair, t times 10 plus t, and that will be the area. Okay, this is just an introduction. I'm not solving a particular problem, but I just want to let you know that that's how we're gonna work whenever we have a geometry problem. So on example 3, we have a square garden, and I did include the picture of the square garden, but with the description that they have there, you can probably draw the picture. So it says, a square garden has a walkway 3 feet wide around its outer edge. So a square garden, draw a square. Okay. Now a walkway, then now picture a walkway in a square garden. That's going to be like a frame in a picture, and it's 3 feet wide. So that means if you're standing right here, the width is 3 feet. Okay, all around is 3 feet. You have, if you extend your arms, that it's gonna be longer than that. 3 feet, 3 feet, 3 feet, 3 feet. Maybe not. Well, whatever. If you have long arms, then it will be. So this is how it looks like. It says if the area of the entire garden, including the walkway, is 18,000 feet. So I'm gonna mark this area right here. Okay, the area of the big square, not the little square inside. The area is 18,000. It's asking for the dimensions of the planted area. So the planted area where the plants are, plant, is this one. Okay, so if they ask me for the dimensions of the big square right here, of the entire area, I could do that. I could say, okay, what side square gives me 18,000? That's something fairly simple. The problem here is that I have to find the area. I'm sorry, I have to find the dimensions of the inside square, for which I don't know the area of. So that's when it becomes a problem. So the first thing I'm gonna do is I'm gonna identify my variable, what it is that I'm trying to find. Dimensions of the planted area. So this will be my x. And I only have one thing I don't know, because once I know the side of the square, I know the dimensions. If it's 8 feet, then it will be 8 by 8. If it's 9 feet, it will be 9 by 9. Okay, so I'm gonna call that side x. You could have called any side of the square x, it doesn't matter, because it's a square, all sides are the same. So I'm gonna call that x. Now I know the area of the black square right here is 18,000. Now I just have to find some relationship between this big side, for which I have some information, and my side that I'm calling x. So definitely the black side and the red side are related somehow. The black side contains the x side, but it's longer. Do you agree? black side is longer than the X side. How much longer? Well, I know that it has, let me use another color. I know it's longer by this much and this much. So how long or how much is this distance right here? Well, it's just the same as the width of the walkway. So this is 3 and this is 3. So the black side is 6 feet longer than the X side or this side of my garden. Now, piece of cake. If this side is X plus 6, how much is this side? Exactly, X plus 6 because it's a square. X plus 6 all around, X plus 6. I'm going crazy with X plus 6 now. Now I'm going to use the piece of information that they are giving me. They are giving me the area. So if I use perimeter, I will be terribly wrong. What is the area of a square, or how do I find it? Is the side square, or this times this, right? So either way that you want to write it, you can write X plus 6 times X plus 6 equals 18,000. Now, as pre-calculus students, you know that X plus 6 times X plus 6 is X plus 6 squared. And now we just have to solve this equation. Remember that when I have something square, I can generate my two answers right away. I'm just going to take the square root on both sides. So I'm going to take the square root here and the square root here. But when I do that, remember that there are two answers always. So these two cancel out, and I have X plus 6 equals positive or negative square root of 18,000. Okay? Now, I'm going to have two answers naturally. So, but first let me get rid of this plus 6. Minus 6 both sides. And I get, this is not cooperating, thank you. X equals positive square root of 18,000 minus 6. And the other answer I get negative square root of 18,000 minus 6. Now, which one would be more convenient for length of a square? So square root of 18,000 minus 6 and negative square root of 18,000 minus 6. Which one will be more appropriate for the length of a square? Well, the one on the top, because it's positive. So X, which is the side of this planted area, is approximately 128.16 feet. So now I just have to write my answer as an English speaker. I know you must be laughing in the inside, but I am an English speaker. Okay, so I will say the dimensions. Now, dimensions is just another word for size. What are the dimensions of the picture that you have of yourself on the fridge? 8 by 6. That means the length is 8 and the width is 6. So dimensions of the planted area are 128.16 feet by 128.16 feet. Bam, done.